everybody. Welcome to today's session. How can machine learning help my career? Today, I'm joined by three ML practitioners as we discuss how and why you should get started in machine learning. First, I have Jyoti Nukula, the principal product manager for AWS Deep Composer. Jyoti, could you tell our viewers a little bit more about your machine learning experience and your journey to AWS?
Yeah, definitely. It's a pleasure to be here, Michael. And as Michael stated, my name is Jyoti Nukula, and I'm the Principal Product Manager for AWS Deep Composer. I look forward to teaching you all a little bit more about how Deep Composer can expand your machine learning skills. And to talk a little bit about my background, I've been with the AWS AI devices team for the past 4 years, and I've been with this team since its inception. And prior to Deep Composer, I had the amazing opportunity to work on AWS Deep Lens, which is another edge device that allows developers to learn about machine learning and computer vision through hands-on and fun projects where where the projects run at the edge, and you can take your ideas from an ideation stage into an implementation stage. And I got to experience and work with some amazing colleagues as part of that machine learning experience.
It's great to have you, Jyoti, and we look forward to learning a lot more about AWS Deep Composer. Next, we have Juv Chan, who is joining us from Singapore, and he actually graduated from the Udacity Machine Learning Nanodegree Machine Learning Engineer Nanodegree program. Juv, could you tell us a little bit more about your career path in machine learning and a little bit more about how you got started?
Hi everyone, thank you for that introduction, Michael. My name is Juv Chan. I'm an AI developer focused on AI chatbot development in the financial services industry based in Singapore. I graduated from 3 Udacity Nanodegree programs in deep learning, machine learning engineer, as well as Intel Edge AI for IoT developer. So I'm AWS certified. I'm AWS certified in the machine learning specialty, and I'm also a winner of the AWS Deep Racer League at the AWS Summit Singapore in 2019. I'm really excited and honored to share my machine learning journey with all of you today. Yeah, back to you, Michael.
Oh yeah, it's great to have you, and you will be the main person I'm leaning on to learn a little bit more about Udacity and how I can get started learning from the comfort of my own home. And last but not least, we have Rahul Suresh, the software development manager for the AI ecosystem at AWS. Rahul, could you tell us a little bit more about your machine learning journey and what you're going to speak about today?
Absolutely, Michael. Thank you for having me. Like Michael said, I'm an engineering manager at AWS, and I'm currently part of the AWS Devices org, where our primary goal is to make machine learning available for every developer. So as part of this endeavor, my group has been involved in launching multiple projects over the last years, including Deep Lens, Deep Racer, and now Deep Composer, which Jyoti is going to be talking about in more detail. Prior to joining AWS, I was working in Amazon Devices, where I helped build and architect a number of smart home products such as Echolook and CloudCam. I have been involved in machine learning for many years in my career, and today my primary interests lie in working at the intersection of cloud computing and machine learning. And I find this area super exciting, and I see so much opportunities in the future.
It's great to have you, Rahul. And to really kick us off, I'm actually going to lean on your expertise. So I think it's only right that if we're going to spend today talking about machine learning, to learn about machine learning at the most basic. So could you give us a brief history of machine learning and why is it such an emerging field today?
Absolutely. And this is a great question, Michael. And before we go into what machine learning is, let's take a step back and look at what artificial intelligence means. So artificial intelligence is, or AI as it's commonly called, is a very significant branch of computer science where the machine learns the ability to do things that normally is reserved for humans and their intelligence. That's the reason it's called artificial intelligence. Machine learning is a specific subset of artificial intelligence where the computer learns to predict or do things without being explicitly told to do so. So instead of giving a bunch of rules to your computer rather learns, your machine rather learns to make the predictions or decisions. For example, you may provide it like 10,000 images of cats and dogs and tell them like, hey, these are the images of cats and these are the images of dogs, but you don't really tell how a cat looks like or dog looks like. And then you feed it through your model, and your machine learning algorithm then learns to differentiate between cats and dogs without being explicitly told to do so. So this is a classic example of how machine learning works. One thing I'd like to call out here is that machine learning until recently was just limited to a few major tech companies because of the amount of compute and compute resources and data that was needed. However, with the advent of cloud computing, machine learning has become so much more commoditized and easy and accessible for every single company, be it a startup or a researcher. All you need to do today is plug in APIs and you get all the benefits of machine learning to you. As a result, machine learning today has proliferated across every single industry, be it finance, retail, healthcare, and whatnot. This is like a really exciting time to be in machine learning.
Nice. So it sounds like everybody on this call got into the field at the right time. And as Raul stated, machine learning is a growing field in the corporate space. According to the World Economic Forum, there will be an estimated 58 million jobs created over the next or by 2022 in the field. However, currently only 300,000 people are qualified. So looks like it's the time to get into machine learning. And so I guess my first question, since I'm here with three ML practitioners, is how did all of you guys get started with machine learning? Raul, could you kick us off?
Absolutely. So I got into machine learning and computer vision during my grad school, and I took a number of courses to help me with the basic foundation of computer science as well as machine learning. Subsequently, I was an engineer at Qualcomm, where I worked on the team that built optimized machine learning and computer vision algorithms for your mobile phone. So that gave me an opportunity to uh, take complex computer vision and machine learning algorithms and make it work on a small device where the power is constrained, where you have to make it fast, and you should make sure that it gives a good experience when you use the phone. That made me understand a lot about how machine learning works and how that is tied to the compute resources on your system. After moving to Amazon, I had the opportunity to take the same machine learning product, however, or the same machine learning ideas, but build services with it at scale. One example is CloudCam, which is Amazon's first home security camera. So as part of this project, we we are able to use a lot of benefits of machine learning and computer vision to make sure that your home is secure through the security camera. Similarly, after moving to AWS, I've been involved with a number of projects. I started off with Deep Racer. Now I'm also involved with Deep Lens and Deep Composer, where we take machine learning and make it available for all developers. So this has really made me understand how much machine learning has proliferated in today's world and how important it is. And I'm really passionate about taking these ideas into the hands of every developer.
So it must be cool for you sitting on a call with somebody who actually has become a champion in Deep Racer in Juve. So
Absolutely. I'm really happy that Juve's here.
So yeah, Juve, let's I think the Deep Racer connection is a great segue. So could you tell us a little bit more about how you got started with machine learning and hopefully give us some tips and tricks to also win a few AWS Deep Racer races?
Yeah, thank you, Michael. Thank you, Rahul. Yeah, so my 5 years ago, when I was working as a cloud developer, I wanted to develop my career into a new career path with a much stronger machine learning focus. So it has since then I started my self-paced machine learning education with online courses such as Udacity, websites, books, open source projects, hands-on labs, which focus on data science and machine learning. And today I'm still continue on my machine learning journey. Um, so I finally got the opportunity to move into a more AI development career in 2018. So which is working as an AI chatbot developer, which I has been working until present. So I believe my continuing machine learning education has definitely played a big part for my career progression from being a traditional full stack developer, cloud developer into my new role in AI development. So yeah, so I really appreciate that.
All right, Jyoti, over to you. Could you tell us a little bit more about how you got started with machine learning?
So my journey with machine learning started a few years back. In my undergrad, I did my engineering in biotechnology, where part of my project was into next generation sequencing. And that's when I came in connection with one of the professors here in the US, who was also working on using machine learning, and therefore I collaborated with him on using machine learning to help identify the biological age of a person from their genomic analysis. And that was my introduction into machine learning. And post that, I worked at 3D Systems, where I was developing 3D printers for consumers. And while we look at 3D printers as a hardware device, there's a lot of software and machine learning intelligence that goes into it, especially to make sure that a part or any image that you give to a 3D printer needs to be assessed by the printer to ensure that it prints appropriately using the material, and also give an error to a user if it thinks the material is too thin or too thick for the design that they have provided. So there was quite a bit of machine learning involved there. And I use some of those techniques to actually print my own drone that I could fix electronics into and then fly around for my own hobby.
Oh, wow.
And yeah, so that was my fun way of getting hands-on with machine learning. And after I joined Amazon, I kind of got to put my passion and my hobby together into the same space, where I'm very excited about new technologies, next generation cutting edge solutions to help our customers. And I was it was at the right time, right moment. I was with AWS Deep Lens, and it was the starting point where we were looking at how do we democratize machine learning to all developers and make it really easy for everyone to get started with machine learning. And after being and working on AWS Deep Lens, I moved on to Deep Composer. So it's been a really interesting journey and a pathway to where I am today.
That's awesome, Jyoti. And I think you're the right person to ask this question. So, as somebody who has no prior machine learning experience or no prior developer being experience, what's the best way for me to get started with ML?
Yeah, so you reached the right person, as you said. So at AWS Machine Learning, our mission is to make machine learning accessible to all developers, irrespective of their skill levels. And so our AWS Edu Devices portfolio was designed specifically to make sure that developers with a variety and diverse set of experience can get hands-on with machine learning, regardless of where their machine learning expertise is. Like, you could be a beginner, you could be a data scientist, an advanced practitioner. There is always something that you can get hands-on with our AWS Edu Devices. So for example, let's say you are thinking about starting with computer vision. Maybe you have a fun hobby that you want to try it out with. Start with AWS Deep Lens, and start with a few projects that we recommend in the console, and then you can get your way into experimenting. Uh, for reinforcement learning, you can start with AWS Deep Racer, where you not just learn about reinforcement learning, but you get to play and win some cool leagues like what Juve did. And for if you're interested in the complex cutting edge technology of generative AI, I would say start with AWS Deep Composer, where you get to learn about generative AI while you're composing music in a very fun, hands-on medium.
So Raul, Jyoti told us the way to get kind of hands-on experience with machine learning through the AWS educational devices portfolio. But if I wanted more of a classroom experience, are there options for that?
Absolutely. I think Udacity AWS Machine Learning Scholarship Program would be a great setting for you to learn about machine learning. The AWS ML Foundations course will help you develop skills, basic skills about object-oriented programming, including writing clean, modular, and readable code. And it will also introduce you to machine learning on AWS with generative AI and AWS Deep Composer. As a result, upon completing the course, you'll be awarded a certificate of completion. You will also have the opportunity to take, if you will also have the opportunity to be eligible for a scholarship program here. So the top 325 students will be selected for scholarships to one of Udacity's most prestigious Nanodegree programs, the AWS Machine Learning Engineer program. Anyone who's 18 years of age or older is encouraged to apply. You must enroll in the program, complete the foundational course, and submit the assessment quiz by July 31st, 2020 to be considered for the scholarship.
All right, so I have about a little over 2 weeks to follow in Juve's footsteps.
Yeah. Absolutely.
So Juve, could you tell me a little bit more about the the ML engineer Nanodegree program and what was really beneficial about that program to your ML journey?
Hi. Okay, so as a graduate from the program, I've learned new skills and reinforced existing skills in software engineering best practices, such as how to write clean code, as Rahul mentioned, as well as more importantly, the machine learning workflows from building, training, validating, and deploying machine learning models to production with AWS machine learning services. I myself, I really like the hands-on projects in this machine learning engineer Nanodegree program, where I get to learn how to use like AWS machine learning services such as Amazon SageMaker notebook instance, Amazon SageMaker Python SDK, etc., to build, train, deploy machine learning models with different machine learning frameworks such as PyTorch, scikit-learn, TensorFlow, etc. So, like for example, like from this program, I've built and deploy a sentiment analysis model for analyze the sentiment of a piece of movie reviews text, and also get to build a plagiarism detection model from scratch. So, so in addition to that, I also get to choose my own real world problem to work on and implement the solution with machine learning methodologies and workflows, which I learned from this program for the capstone project. So, so I did choose a real world problem from like some of the from Kaggle competition. Yeah. So so I was able to apply these skills that I learned from here to my career as well. For example, like I've learned the skills from here on how to able to build and improve my the natural language understanding model for the AI chatbot, which I've been working on at my work.
Nice.
Yeah, thanks. So I really look forward to continue to apply the skills from that I learned from here, and I'll really love to try to build some open source projects using Amazon machine learning services.
All right, that was a glowing recommendation. So I know I'll be enrolling as soon as we wrap up this webinar. And then I guess my last question for you guys, and then we can start with Raul. What do you think is the biggest opportunity for ML as we go forward?
I think in my opinion, ML, I'm not going to single out any single area or application because like I said before, I think machine learning today is in a very interesting phase where science has progressed a lot, and due to all the cloud computing advances, it's getting more and more accessible to a lot of people. So in my opinion, the biggest area is just the proliferation of machine learning into every industry, and it's no more going to be restricted to big companies or teams which have scientists in them. Today, I think machine learning is something that every developer, you or I, can think about machine learning and easily plug it into our application. And this could have a wide-ranging benefit to the society and people using it. But individual developers can absolutely make the choice to use machine learning wherever they want, and that's the beauty of it. It's so easily available today that it can make a widespread impact in pretty much any industry you think about.
Yeah, so Juve, as somebody who is already taking full advantage of the opportunity ML is presenting, what do you think is the biggest area for growth of ML?
In my opinion, I think the biggest opportunity with machine learning going forward will be AI for healthcare. For example, like how machine learning can help to develop an effective vaccine to fight against like today's pandemics in a much faster and effective and cost and also cost saving. Besides, I think like the combination of AI and robotics for AI healthcare can be used to curb the spread of pandemics more effectively through like automated disinfections in the public areas and also like maybe on the area of quarantine monitoring. Yeah, that's my opinion. Thanks.
And we'll wrap it up with Jyoti. And what do you think is the biggest area for growth of in machine learning as we look forward?
Sure. I would say machine learning is already all around us. For example, if you have ever said, Alexa, turn on my lights, you have used machine learning. If you have used maps to navigate from place A to place B, you have used machine learning. So machine learning is already around us. And I think the value is in the fact that more and more research is being done to make models that are leaner, that can run on devices that don't necessarily need heavy computing power, lean devices or lean models, I would say models that can run at the edge. And the other aspect is that as these models grow more robust, you start seeing companies applying machine learning for product development, product design, and even for making machine learning models itself robust. Like what generative AI is being used for is to create synthetic data that can make your machine learning model more robust. Like for example, if you're an energy company and oil and gas or energy company, and you want to create a model that can detect both positive and negative leaks. Like positive would be no leak, but then a negative would be when there are leaks. And so you would want something where your machine learning model is able to now detect and be more robust. Similarly, you want to have your model more robust across different data representations, and you would want to use generative AI to create those synthetic data sets to make your model robust. So I would say that machine learning, its ability to detect patterns and identify and get as close to as how we look at analyzing objects. I think it's a very growing and booming and advancing field.
All right. So by all accounts, everybody here would say that right now is the best time to get started with ML, and you can get started with Udacity or with the AWS educational devices portfolio, and it's in your hands to really get started. So that wraps up our roundtable session. And now I'm gonna hand over the reins to Raul and Jyoti to give you guys an exclusive AWS Deep Composer demo.
Thanks, Michael. Let me walk you through the AWS Deep Composer console. I'm super excited to be giving this demo here for our Udacity audience. As part of this demo, we'll go through a couple of algorithms. We have a generative AI and an auto-regressive CNN algorithm available in the console. So I'll walk you guys through it. Also, there is learning capsules for those of you who want to dive deep into the concepts of generative AI and learn its technique. There is learning capsules available in the console. And once you create a composition, don't forget to participate in the Chartbusters challenge that is currently running right now, where you get a chance to top the charts and win some prizes. So that's something everybody can participate in as well. So I will show you how to create a composition and then how you can submit that composition to Chartbusters challenge. Let me share my screen now. So I'm already on the AWS Deep Composer console, but if you want to log in, you can go to console.aws.amazon.com. Make sure you're in North Virginia region. If you're not, you can choose the panel to choose North Virginia region, since Deep Composer is available only in the North Virginia AWS region. So this is the music studio in AWS Deep Composer. As you can see, we have provided a couple of sample input melodies if you want to get started. And you're not, let's say you're not comfortable with playing on the keyboard, you can use some of the sample input melodies. Like me, I'm bad at playing a piano, so I'm going to just save everybody here and just use the sample input melody today. And on to the right, you can see that there are different parameters that are available. So you have two generative AI techniques that are available. One is GANs, which is the generative adversarial networks, and the second is the autoregressive. Now you may be wondering, what is GANs? What is autoregressive? How are these two different? And to help people get started with these concepts, we've added learning capsules. You can access the learning capsules by using the left navigation pane and go to learning capsules, and you can see that there are two capsules available that you can use. Each of these capsules provides bite-size concepts that you can use to learn about these techniques and understand the generative AI concepts in detail. So now let's get started with going back to the music studio. I'm going to choose this generative AI technique called autoregressive. Once you take this autoregressive technique, you need to choose a model. And there's only one model available, which is autoregressive CNN Buck. So I'm going to choose that model. But before I get there, let's hear the input melody, Twinkle, Twinkle, Little Star, as it stands. Well, so that was our Twinkle, Twinkle, Little Star. Now, coming to the advanced parameters, you have 4 different parameters that you could tweak for your generative AI model. So the first parameter is the maximum input nodes that the algorithm can remove. And so this is based out of percentage. So let's say if you say 100% of my nodes it can remove, then the model is going to identify all these places in the melody that it can that's probably not similar to your Bach composition, and try to tweak that. Similarly, you have maximum nodes that the algorithm can add, and in this case, the algorithm is going to automatically decide based on the tune if there are places in there that it can add to make your composition sound more Bach-like. And sampling iterations is the number of actions that your model can take, and your creative risk is in terms of what sort of deviation you want in your composition. One is a very low risk, and 6 is a very high risk in terms of the diversity in the composition itself. So I'll probably do a couple of iterations across these and you can see the difference. So first I'm going to just change one note here. So I wouldn't say 100, I would probably say, let's choose 80. And then I'm going to keep all of this at 0 so you can just see that difference. And I'm going to keep the creative risk at 1 because that's not going to really impact. And now I choose enhance input melody, and now I have my new composition right here. So you can see that some of the notes here have been tweaked than what it was before, and this is the algorithm that's trying to make it sound more Bach-like. Let's listen to it. You notice some difference, but not a lot of difference because we just tweaked one parameter here. So let's say we keep that at 80, and then I'm going to increase the maximum number of notes. So let's say I'm going to make it 70. And I'm going to keep the creative risk the same. Notice how the pattern over here, the notes are going to change. And so you can see that the model did make some changes, minor changes to the notes. So I'm going to now play composition. So then now let's try to increase the sampling iterations, which is the number of actions that your model can take. I'm going to make it about 90 here. I'm going to say enhance input melody. There you go. You can see it's introduced a couple of notes in here that can make it sound more Bach-like. So I'm going to play the composition now. Okay, now let's increase the creative risk to maybe 4 and enhance our input melody further. Let's listen to it now. So this is just one iteration. This is just one time I've tried different things. The beauty is only when you try different ranges, different parameters, you experiment with it, and that's when you can see how the algorithm works with your input melody to make it more sound Bach-like. So now let's say, for example, I want to reduce the sampling iterations further down to maybe just say 40. I'll keep the creative risk the same. I will keep maybe maximum notes to remove. I'll increase it to 90 and then keep this at 80. And then make this move, bring this to 3. So you can see I'm really experimenting here. There is no one one sure short way to get to how you want your composition. That's how two people can start with the same input melody and it'll still be different after a couple of iterations. So I'm going to enhance my input melody. Let's listen to it. Okay. I want to further make some changes here. I'm going to further make this, probably I'll increase this to 50. And I'm going to enhance this. Getting there, but not there yet. So I'm still going to go ahead and keep enhancing it until I find it comfortable. So let's try this again. Let me do it a couple more times with the same parameters. So I'm just going to pause here for a second and then go ahead, just in the interest of time, go ahead and enhance it further. So you can see that it no longer sounds like what it started. It's sounding more and more like it's coming closer to a Bach symphony. And so I'm going to go ahead and enhance it further. Let's listen. There you go. That's an example of how with repeated experimentation and some parameter tweaking, you can get your composition from where it started to something that is inspired. And let's say I like the way it is as it is, and let's say I want to submit this to Chartbusters. I will make a note of this, composition 36. I will go to Chartbusters. So the current Chartbuster challenge is Back to the Future, where you use the autoregressive CNN technique. That's the technique that we used in the demo to generate compositions in the style of Bach. And so I want to submit my composition. And so I'll choose Submit a Composition. And so I'm going to choose an existing AWS Deep Composer composition, which is the Comp 36. I'm going to choose that. And you need to sign into SoundCloud and then hit submit. And this will automatically submit to the playlist on SoundCloud. And we'll have the winners announced on July 31st. So I'm really excited to see the compositions that you create while you're learning about generative AI. And as I said, if you want to learn about the concepts behind autoregressive and GANs, you can use the learning capsules and get through to understand the various concepts. So that's what I have for the demo here. Over to you, Michael.
All right, thank you, Jyoti. So I hope you guys appreciated that walkthrough through AWS Deep Composer and take full advantage of the opportunity to be your own producer and participate in the Chartbusters Challenge. I'm excited to see what you guys all come up with, and I'll definitely be adding the best songs to my playlist. And Ju, Raul, Jyoti, I really wanted to just thank you guys all for taking times out of your busy schedules to come speak with our viewers today a little bit more about how they can pursue a career in machine learning. And so everybody be sure to enroll in the Udacity AWS ML Scholarship Program and complete the foundational course so that you can take the assessment in the hopes of getting one of the 325 scholarships to the Nanodegree program.
Thank you, Michael.
Thanks,
All right.
Michael.
Thanks,
Thank you,
everybody.
Michael. Thank
Bye.
you.
Take
Bye.
it easy.
Bye.